Hello everyone, I'm myself Navya and I'm here with my teammates Gautam and Bhargav, presenting you our project on image segmentation using Maskar CNN and GrabKit.
Hello. In this, we are cloning our project with Maskar CNN from a GitHub repository. This is the code. And in Maskar CNN, there are certain .py files which are used for pre-training the model. In this model.py file is the important file. It is the actual definition of Maskar CNN model. In this, we will do the region proposal networks, which are useful for bounding the shape of an object and making it clear pixel wise. Next, we are importing some important files which are used in this project. Those are OS file, that means operating system, which are used to open files, and skimage.io, which are used to open, read and write images. Matplotlib for making graphs or objects, and NumPy for graphs and arrays to manage arrays, and TensorFlow for using the model. Then by using MRCNN, we import some utilities and then model lib and visualize, and we'll import visualize to visualize the object. From now on, Navya will continue.
So this code snippet sets up the environment to use Maskar CNN with Coco dataset. It defines the path to pre-train the model weights and download them if they are not readily available. The code creates a configuration for inference, specifying settings like GPU count images processed by per GPU. These are the configurations characteristics of the COCO model, COCO dataset. And here in the first line, it describes the prediction of the dataset and the model. And then in the next line, it loads the pre-trained weights into it from a specific path. And the next snippet shows the particular names, particular pictures of these which our dataset, our model could run. And next here in this code snippet, it generates a random 10 into 10 numpy array filled with integer values between 0 and 255 and assigns to it the variable masks. It also sets a threshold value of 128.
So to perform the mask RCNN model, we are taking an image from the Google in which there are two elephants. So to visualize the display, we are using ROS, mask, class ID, and shape. So the ROS generally marks the elephant, and the class ID displays which category it belongs, and the score is the predicted value. So we are using a Streamlit to run the web-based interface as to perform the model. So we are using a GrabCut model to extract the image. So we are giving an coordinates or the dimension for every image for x1, y1, and x2, y2. So we got the extraction of the elephants by using a GrabCut model.